Good morning, everybody. My name is Gertjan Burghouts. I'm with TNO. It's a research institute in the Netherlands, about 3,000 people. I'm in the intelligent imaging department, where we are involved with artificial intelligence and applying it to image analysis. I will share with you some insights how domain knowledge can be used to improve AI. So, my name is Gertjan Burghouts. I'm 42, married. I have 3 daughters. I live in the Netherlands, in Amsterdam. My work is about AI on images. So we use robotics. We work for a DARPA project about learning with less labels. And I collaborate with universities like the University of Amsterdam. Part-time, I'm also a scientist on the job. So here you can see that we have, here we are working with the police, for instance, for aggression detection. And we're also working on forensics and intelligence. I also like to keep track of academic advances. So I edit a blog, and I also have a YouTube channel where you can see some examples of our applications. So I come from a computer vision background. And so my deep learning perspective in this talk will be about images and video. But I think the ideas are general and also applicable to other modalities such as text. Here you can see the abstract. In this talk, I would like to focus on adding domain knowledge to a learned model, dealing with few labels, and also I will be talking about uncertainty. So for instance, I will show how to classify a very particular instance, not a class, but an instance. I will also show how to classify something that has not been seen before during training. And I will also talk about uncertainty and how to avoid false positives, which is key to applications. As a first example, I want to show you this slide. Find my pink car. So there's tons of object detection models around that detect objects in images, but they detect classes, not instances. So you will find that a model will detect 47 cars in this image. But actually only one is relevant because the pink one is the one we're interested in. So can we improve the selectivity of a learned car model? And the way that we do that is by adding knowledge on top of this learned model. So here we have knowledge about the color being pink, and we add that to the model on top of it without retraining. We don't want to retrain because, for instance, in robotics, we want to quickly adapt what to find while not retraining, because that can take hours or even days. And so we want to include it on the spot. Here you can see how we do this. So we have a model. In this case, we're looking for a person with a green sweater inside this house. We have a deep learning model that tells us how to recognize a person and a sweater. And we add the knowledge about the sweater being green on top. And that enables us to do the image on the right, namely to select from all of these persons, which are detected by the default model, and then only down select the ones that have a green sweater afterwards. So this helps us to make the search of Spot, the robot, more specific. And that has additional advantages. So we can also tell Spot to go through a yellow door, because we now can combine the model for door with the fact that we know that it's a yellow door. So we can add that on top. And likewise, we can do that for a green wall clock in case that we know that, for instance, the living room where Spot needs to go has a green clock. So we can tell Spot to look for that. Okay, so we have put knowledge on top of a learned model, but sometimes we also want to relearn the model. And if we want to find something that we did not see before, like in this case, an old timer, suppose that we want to recognize them on images, we typically start annotating. But it's a tedious job. It's costly, it's time consuming. While there are actually many datasets around. So for instance, visualdata.io and many other websites, they have an inventory of all of the different data sets that are around and even very up to date. So next week will be NeurIPS 2021, and even the newest data sets are on there. So if there are so many related classes in such data sets, like for a car, you can find a pickup, a race car, a Jeep, a cab, minivan, and so on. Can we leverage that to avoid the costly annotations? And that's what we did. So here we have all these related classes, and then we have annotations that we get for free. If we all merge them together, we hope to get a better classifier for a car, and such that we can also find old-timers which you did not see before. So we learn a deep learning model, in this case DeepLab V3, and we can hopefully generalize to unseen, such that we can also recognize old-timers. And actually, that is what happens. So if we generalize with all of these related classes, we can find big trucks, we can find London buses, and we can also find old-timers. So the message is that we can leverage other data sets for our purposes. Okay, so what if we really have something new that's not in a data set like that? So for instance, a zebra. And we want to predict it, but we don't have images of it, not even one. But we know what horses look like, and we know what tigers look like. And actually a zebra is the combination of the shape of the horse and the stripes of this tiger. Can we leverage that? So what we have done, and we will present this next week at NeurIPS, is that we took a lot of images and their classes and some attributes like their texture, for instance, stripes, and we put that together in our model called Protoprop. And what it does, it looks at shapes, being the top row, showing the horse and the other animal shapes, and the bottom row, showing the different kind of textures or properties. And then we can take the shape from the horse and the stripes from the set of representatives, and we can merge this into a new concept of zebra and then recognize it whenever it encounters. Okay, so this is the full model. So we also do this for other animals. So this model will learn how to combine shapes and textures, and then we can generalize to new concepts like this zebra. So it combines the horse and the stripes. Okay, I've been talking about adding knowledge to a model. I've been talking about how to leverage data sets and properties that have been annotated for other related classes, and then how to generalize. And now I will talk about uncertainty. So here we want to put AI in an application. And what it means is that often in applications, we let the AI in the open world. So it's not a closed world. It does not consist of only the classes and the training data you have been encountered before. You will probably encounter new data and also new classes. And so that requires robust and safe operation, especially in the case of a robot like Spot, which is heavy, it can move fast. You want it to operate reliably, especially when interacting with humans. Well, standard deep learning is not very good at this open world problem. So here we have been training on 3 types of fruits. This is a gaggle competition. And now we have a new type of fruit or vegetable. And standard deep learning will say it's very confident that this is a pear. That, of course, doesn't make any sense. And we've been working on uncertainty and to put that into deep learning models. And for this image, it will say it doesn't look like any of the 3 that we've been modeling. So you can see that the prediction is in the middle of 2 of these fruits or vegetables, and that means that it's uncertain and that we should not trust the output for this case. It's not one of the 3 classes, it's something different. And this is very important to know, because for instance, if Spot enters an unknown place and it knows that it's unknown, then it's going to go into safe mode or ask for assistance. So we have done an experiment. Spot enters different rooms, and we've been modeling these rooms.
Malce tiše, prosim.
We need to test out the share screen option with everybody who will be sharing the presentation. And we should start
Tech support, can you please mute?
Help me and invite
Yes.
of your speakers.
Please tell me if there...
So there's three types of rooms, and we have modeled them so we could train them. So for instance, in the home environment, living room, bathroom, and so on. In the work environment, an office or an operating room. And in the public, you can see, for instance, the airport or the subway. These are all learned during training. But how to deal with unknown scenes? So for instance, a shop or store. And so these are withheld from the training set, and we test what happens if we encounter them. Well, for known scenes like the living room and the office and the dining room and so on, that's very easy for standard deep learning because it has been trained to recognize these. But unknown scenes are very hard. And with our model shown here in the colored squares, you can see the outliers. So this jewelry shop, it's an outlier. It doesn't look like any of the known classes. It looks most like office, but it's too far away. So we will say that it's an unknown scene. And this is very important because then Spot can tell, I'm in an unknown place, please help me. And the same happens for instance, for grocery store. It's close to red, but it's far away. So we say it's an outlier, it's an unknown. Okay, as a summary of my talk, I presented that domain knowledge gives AI models more contextual awareness. It's very helpful because it improves specificity, like higher accuracies, finding a pink car instead of all cars without retraining and by adding knowledge. Efficiency, so less labeling required, meaning faster deployment. So recognizing this old-timer because we modeled related vehicles. And also in terms of reliability. So there's more robustness when we model the uncertainty that helps to reduce false positives and also more robust operation. It is the same training data, the same model, it's just a different way of training it. And that's very helpful. This is the summary of my talk. I hope it was interesting for you. And if you have questions, I will be happy to take them. Thank you very much.
There are no questions in the chat so far. Maybe we'll wait a little bit for questions to come up.
Sure. Yeah, let's do that. I also heard there is a bit of a latency, so let's see if questions arrive.
Okay, I see that there are no questions at the moment, and the platform does not support live questioning through voice, so it's the chat channel which is the only way for the audience to interact. I think your contact details are clearly laid out here.
Yep.
And I think it's a very applied and a relevant type of research that you're showing, which is going into things that are quite not yet so often seen in practice. So I think it is a very interesting piece of research that you just presented, Gert-Jan.
Thank you, Freek. And I will be happy to take any questions or follow up if people contact me or any of the other tech support or Freek. So happy to follow up on this work, and thank you for your attention.
Okay, yeah, thank you.